So what are retrieval-augmented generation systems, or more commonly known as R.A.G, and how does it differ from a traditional AI model? So R.A.G systems combine two components: a retrieval system that pulls relevant documents or data from a knowledge base, and a generation model like GPT, which synthesizes responses using the retrieved data. And unlike traditional AI models that rely solely on pre-trained knowledge, R.A.G dynamically retrieves external up-to-date info to improve accuracy and relevance. So some use cases of R.A.G systems and which industries have best adopted these so far, starting with customer support. So customer support, you can automate responses using up-to-date product documentation. Healthcare is a great one too, where doctors are assisted by retrieving clinical guidelines to answer patient questions. And legal research, where lawyers and paralegals can extract case laws and generate summaries for legal professionals. And in e-commerce, product recommendations and answering facts based on a retailer's catalog is another great use case. Education is another great use case where teachers and educators can tailor learning resources by retrieving content relevant to any student's query. So some strengths and key advantages of combining retrieval mechanisms with generative models in R.A.G systems. You get improved accuracy, right? So you have access to external data, which reduces reliance on potentially outdated or incomplete pre-trained knowledge. You can also scale it way better because retrieval ensures the model doesn't need to memorize all information, which would require massive computational resources. And you also have adaptability because new knowledge can be added to the knowledge base without retraining the entire model. So what are the most common challenges when implementing R.A.G systems, particularly in handling large-scale data sets? Latency is a huge one. So retrieval from large knowledge bases can slow down the response time. Data quality as well. If you have inaccurate or unstructured data, that's going to lead to poor results. And then complex integration. So you want to seamlessly connect retrieval and generation components, which requires really careful engineering. And it can be difficult to assess whether the retrieved documents are actually the best match. So now let's break down the typical architecture of an actual R.A.G system. So the retrieval and generation components interact, but they're both different. So you have the data indexing, which is where the knowledge base sits, and it's indexed using tools like Facebook's FAISS or Elasticsearch. You also have the retrieval module, which is a retriever like dense vector retrieval, which pulls documents based on a user query. And then the generation model, which is a language model like GPT-4 from OpenAI, which takes the retrieved documents and query context to generate responses. And you also have a feedback loop, right? Because that's going to bring continuous updates to the knowledge base and fine-tuning to ensure performance. So what role does the quality and structure of data play in the performance of R.A.G systems, and how can organizations optimize their data for these systems? Number one is structured data. You want to use well-organized, clean data like JSON or database formats for better accuracy. And your knowledge curation has to be on point as well. You want to remove any outdated or irrelevant information from the database. And if you do have metadata, you can enrich all your data with metadata to improve retrieval accuracy. So how do R.A.G systems integrate with existing workflows and platforms, and what should companies consider when deploying them? API integration is a huge one. You want to provide APIs for retrieval and generation components to interact with enterprise applications. Knowledge base updates as well. You want to automate knowledge base synchronization to ensure it's always current and up to date. And finally, security. So you want to ensure the retrieval system respects data privacy and handles sensitive information securely. So where do we see the future of R.A.G technology heading? And are there any upcoming innovations or improvements on the horizon? So one thing is hybrid models, where R.A.G is combined with reinforcement learning for continuous improvement. We also have domain-specific R.A.G, where we have pre-built R.A.G frameworks tailored to industries like law, medicine, or finance. And finally, edge deployment. So if you want to deploy a lightweight R.A.G system for faster online processing. And explainability. You want to improve the transparency in how documents are retrieved and used for responses. So what are the ethical implications of R.A.G systems, especially regarding bias in retrieved data or the potential misuse of generated outputs? So you want to regularly audit the knowledge base for biased or inappropriate content. And you want to make sure you actually inform the users that generated outputs depend on the retrieved data's quality. And finally, oversight. You want to use human review for sensitive applications like healthcare or law to really make sure everything is nailed down.